Well, that's been happening to me lately a lot. There must be something going on with my computer. It's all of a sudden not able to handle GoToMeeting in full.
Huh, that's weird.
Yeah, it's like I've lost some horsepower or something. Anyway, are we going back to this page here for today?
Yeah, we are on 12.1.
Okay.
So I don't understand this at all. I tried to go in for help today, and the teacher I go in for help wasn't there, so...
All right, let's see here what this first one is. All right, let's see if we can draw a picture of this. Hold on a second. Let me get it like this. And put this under here like that. What do we know about this angle right here?
That's half of the full length.
Actually, what we know is that it's a right angle. When lines are tangent to a circle, they make a right angle with the radius.
All right.
So if I redraw this figure, what I've got is this. This is BC. This is a right angle. This is a right angle. And this is AD. And they're saying that this is 11, that BC is 15, and that DC is 3. And they want to know what AD is.
All right.
Well, how could I figure that out? My choices are 14 to 17.
14 to 17.
That's my, oh, excuse me, that's for number 3. No, that's for number 1. Yeah, it's multiple choice. So my answer is somewhere between 14 and 17.
All right.
Right offhand, it's difficult to figure out what AD is. But what if we create a rectangle?
How is that? Okay. All right, I see it.
What is this dimension here?
15.
What is the dimension from here to here?
Half of 11, so 6.
Half. What is the dimension from here to here based on its other side?
-3, so...
Well, not -3, 3. Which makes this one 8.
Oh, I'm sorry. I thought you were pointing to... I can't really see that red cursor, so... that you were...
Okay. Well, what I've done is I've taken this trapezoid and broken it into a rectangle and a triangle. Once I do that, I know the side. Now I have a triangle that I have to solve.
And to do that, it's
8, 15, and I know this is a right angle. So what's this side here?
so you do 8 squared plus 15 squared, and the square root of that is 17.
And that's another Pythagorean perfect triangle, an 8, 15, 17.
All right. Easy enough.
let's see, if all of these lines are tangent to the circle, JA is 8, AL is 13, and CK is 11. What is the perimeter of that triangle?
J to A is 8, A to L is 13, becomes 15, and then C to K is 11.
Let's see if we can figure out how to do this. Now, it is possible that there are some special formulas that apply here that I'm not remembering from we do have some, but I don't think so. Let's see, JA is 8, AL is 13, CK is 11.
All right.
And in order to find the perimeter, we need all the other sides. Okay, there is a particular geometry theorem at play here. If JA is 8, what is JB?
8.
Because we know that if two tangent lines intersect, they are equal. In other words, that's equal to that.
All right.
Okay, so if this is 8, what is BK?
13.
BK. Going clockwise.
Yeah.
Well, BK would be the same as CK, which is 11.
How is it the same?
Well, because this tangent line is the same as that tangent line in length.
Oh, because those two are the ones that are
Those two are the
intersecting.
ones. Exactly.
Okay.
Okay, now how about LC?
That would be 13.
Now it's a simple matter to add everything up.
All right.
So we have 8, 13, and 11. That's 32 twice, 64. Is line AB tangent to the circle, why or why not? The diagram is not to scale. What would make it tangent?
Well, you do the hypotenuse of that triangle there and see if it all adds up to 5 squared.
First of all, let's start with the theory here. What do I need to show to say that that line is tangent?
I don't know.
You need to show that this is a right angle, because it's only tangent to the circle if it makes a right angle with the radius. So,
okay.
Is that a right angle?
That one is, yes, but...
Well, no, it really,
not the one...
you can't tell. It's not drawn to scale. So they're not putting the right angle in there. I put it in there because I don't know. It's only a right angle if the Pythagorean theorem applies. In other words, if the hypotenuse squared is equal to 9 squared plus 12 squared, then it's a right angle. If it is not, it's not a right angle.
All right.
So what's the hypotenuse length?
The hypotenuse length would become 15.
Where do you get that from?
9 squared plus 12 squared. Or the square root of that.
Okay, so it should be 15. What is it?
That's what it comes to.
That's what it's supposed to be to make this a right angle, but all radiuses
Oh,
are equal. So this radius is 9. So the hypotenuse is only 14.
how are you? Okay, I see.
All radiuses are equal. So this radius of 9 is the same as this radius here. And 9
Okay.
plus 5 is 14. So this hypotenuse is 14. Now,
Okay.
does a 9, 12, 14 triangle equal a right triangle?
No.
So the answer is no, and it's because 9 squared plus 12 squared is not equal to 14 squared.
14 squared. Right.
In other words, you kind of have to work backwards with some of this. Pythagorean theorem works both ways. If the sum of the sides equals the hypotenuse squared, it's a right triangle, and the converse is true. If it's a right triangle, then the sum of the squares equals the hypotenuse squared. Okay. Is line AB tangent to the circle? Why or why not?
No, because there's no, because there's no right angle. Or it doesn't.
How do you know there's not a right angle?
Because they didn't draw it in there.
That doesn't mean there's not a right angle. They wouldn't draw it in there because they're asking you, is that a right angle? The whole question is ABO a right angle? And how can you tell?
Pythagorean theorem.
Okay. So is 12 squared plus 3.5 squared equal to 12.5 squared?
Yes, it is.
Okay. So the answer must be yes. 12 squared plus 3.5 squared is equal to 12.5 squared.
Right.
That makes it a right angle. And that makes it tangent to the circle. Get it? Okay.
Yep.
Okay. Number 5. MK is equal to ML. Let's draw this one. Wow. Reasonably good. M, L, K, and A, B, C. MK is equal to ML, and the perimeter is 32. And LC is 4. And A, B, and C are all points of tangency. What is KA?
Yeah, no. We don't know that one.
Do we know LB?
No.
Actually, we do. There's that theorem that says if you have
so it's
lines,
4.
so that's 4. And we know that AK is equal to BK.
Right. So it would be 4 as well.
They're telling us that ML is equal to MK. And we know that MC is equal to MA, right?
Right, so it would have to be 4.
Well, exactly. The only way K would have to be 4 because ML to be equal to MK, we know that MC is equal to MA, so AK has to be equal to CL. Okay.
Then I'd have a 12-2.
Okay.
So for this, yeah, this one on number 1, would you draw the radius in like a different way?
Yes.
I don't know. Okay. So forming a right angle so you could do Pythagorean theorem, right?
No. Oh, yes. Yes, exactly. Let me do it. So how do I want to draw the radius?
So the radius comes out there, and then draw it to an angle forming that right triangle. Yeah.
Okay, we know this is 4. We know this chord is 14. How far is it from here to here?
Half, so it would be 7.
Now you can figure out the hypotenuse. What's the hypotenuse?
8.1.
Well, tell it to me. It's the square root of what?
The square root of 7 squared plus 4 squared.
Okay, so that's the square root of 16 and 49, 63. And that's the answer. And, did I do my math wrong? 49. Yeah, 65. Square root of 65 is 8.1. I knew the square root of 63 was not 8.1. Yeah, because all radii are equal is the principle. You got two principles at play here. First of all, if you have a chord at a right angle to a radius line, the radius line bisects the chord, which makes this piece 7.
Right.
And then when you draw the radius in a different way, all radii are equal in a circle. So this radii has to equal this radii here. And you can calculate that radii using the Pythagorean theorem.
Right. So she was talking about yesterday when you have roughly the same kind of question that you double it. When would you double it?
I do not know. Not sure what she's talking about.
And then this is the same problem.
So what's the answer to 2?
6 squared plus 8 squared.
What kind of triangle does that make?
It forms a right triangle to make x equal 10.
It's a 6, 8, 10 triangle, or a 3, 4, 5. It's a multiple of a 3, 4, 5 triangle. In other words, you can do that without having to resort to the Pythagorean theorem if you recognize it.
All right.
It's always nice if you don't have to use the Pythagorean theorem. You know, if you recognize a 3, 4, 5 triangle or a 5, 12, 13 triangle or one of those.
Right. Huh. Well, confused on 3.
FG is 40.
Right, which would,
What's RS equal to?
it would have to be 40 as well, wouldn't it?
Okay. So if OP is 12, what is OQ?
12 as well.
Correct. As long as these two chords are the same, then perpendicular intersectors from the diameter have to be the same. Notice that if this chord here was longer or shorter than 40, this measurement would not be the same. If I made it shorter and made it like that, this measurement would be longer. But as long as these two are the same, there's no way to put it in the circle without these two being the same. So 12.
All right. Would you just set these equal to each other?
Yeah, notice that this chord up here is the same length as this chord down here.
Okay, so X
Again, the only way that can happen is if this angle is the same as this angle.
All right.
So 46 is equal to X plus 4.
42.
Mm-hmm. Okay. Now here's a case where those distances are not the same. In other words, we have this chord here, and we have this chord here. And the only thing I could say is if this chord was the same length as this chord, this distance would be the same length as that distance, correct?
Right.
But they're telling us that CM is 17, which makes CD 34. They're also telling us that this distance here is 8, and this distance here is 9, which means these two chords can't be the same because it's not the same distance.
Right.
This distance here would be 17. So they want to know EN. EN, this distance right here, we'll call it X.
How would you find that then?
Well, if we
Could
can
you turn it into a right angle?
Well, we can turn it into a triangle. In other words, if I could figure out the radius, I can solve for X. Because we know this is a right angle here.
Right.
Well, how can I figure out the radius of this circle?
The radius? I don't know.
Both of my dotted lines are radii.
Well,
can I solve the triangle on the left? Can I solve that triangle right there?
Yeah.
Go ahead. What's the hypotenuse?
The square root of 17 squared plus 8 squared.
Okay. What is that number?
18.8.
18.8?
Yep.
All radii are equal, so this one's 18.8 also. Because they're both radii. Okay. And now what is X going to be?
So you do 18.8 squared minus 9 squared, and then you square root that. And X becomes 16.05.
Now that's not on there because they left it in radical format. Which answer that you're looking at there is going to be equal to 16.05?
4 to the 34th.
What's the square root of 34? That's not 4 to the 34th. That's 4 times the square root of 34.
Right.
Approximately, what's the square root of 34?
5.83.
Is 4 times that equal to 16.05?
No.
Okay, so let's look for another answer. Which answer on there is the closest to 16.05? What's the square root of 17?
Square root to 17
is going to be 4 and change.
Right.
4 and a very small number. So if I take 4 and a very small number and multiply it by 4, bingo.
Okay, that makes sense.
Okay. That it? Just 12.1 and 12.2?
Yeah. She broke it down into 2 parts, and then she comes up with a reason to give us a quiz on it.
Okay.
So.
Wow, this is about it, huh? This is the last one.
Yeah, and then I think we get a new book, and then it's a different website.
So you will do some more new material. I was thinking maybe they're done.
So.
Maybe they're done with new material for the year, and you're going to spend the last month. When is school out? How long do you go to school?
Until May 28th.
So another month and a half almost, maybe a month and a week. So, yeah, unless you spend that whole time reviewing, you will have new material, I guess. Okay.
Yep. So.
Okay. So you want to call it a session? That's all you need to go over?
Yep. And then this will be on YouTube later tonight, right?
Let me see here. Let's see. I can't start processing it until I'm done with my online sessions. So it's liable to be first thing in the morning.
Okay.
It may not take that long to process. It's only a half-hour session, but I'll get it up there as soon as I possibly can.
Okay, awesome.
Okay, Ryan?
Alrighty, thank you.
All right, you're welcome. I'll talk to you next Wednesday. Let's see. Hold on a second. Okay, so we're scheduled for Monday and Wednesday. All right.
Yep.
Okay, sounds good.
Alrighty, thank you.
Bye-bye.